I don't know if you all remember. Oh, that's a long time ago. So let's move on. All right. So our story, well, from last week starts in Romania in the year 1845, and the ghost name, well, she's a ghost now, but back then when she was alive, she lived in around 1845, and she and her husband went on a little expedition in Romania. And as you all remember, a wolf showed up, right? And of course, we had predicted that this story would either have to do something with werewolves or vampires, right? Somewhere around there, right? So let's get to the first piece of theory here, right? We're going to start off with something a little bit easier than what we've been doing all the time. This here is a new type of transformations. But look at the word here, right? This is what we call a translation, right? I know the words resemble because the main name of the topic is transformations. Well, when you hear the word transformation in maths, you think about reflecting in the x-axis, reflecting in the y-axis, doing enlargements, doing rotations. And on the first day of class, I would have given you about 7 or 8 matrices to learn off by heart, right? How to rotate, how to reflect. Now, all the questions we did so far had to do with multiplying the points on the shape. Keyword, multiplying the points by the specific matrix. Today, when we're doing translations, the good news is there is no multiplication. How much of you all think that is good news? Instead, when you're doing translations, also known as sliding, you only have addition and subtraction to do. So whenever you hear translations, right? Whenever you hear translations, it only deals with addition or subtraction. So I just always tell students the translation part of transformations is the easy part. And anytime you see a translation question come, smile, because it's one of the easiest questions you will ever do. Also, another piece of good news, whenever you have to do translations, other than the fact that it's addition or subtraction, the matrix is a small matrix. It's not 4 values, it's only 2 values. So that's another good piece of news. And here's how it works, right? Whenever you're given a translation, you're going to have to take the shape they give you, and I will be doing quite a few examples, and you're going to be moving it either horizontal or vertical on the graph paper, or a combination of both. You can move it horizontal and vertical as well. The truth is, whenever you're doing the translation, it doesn't matter if you do the horizontal piece first or the vertical piece first. You can do it in any order. But just to have some coordination in class, we're always going to be doing the horizontal movement first. Now, if you're moving something horizontal, you can either move it to the left or you can move it to what? The right. Think about it. If you're moving something horizontal on graph paper, it's either you move it left or right. If you're moving something vertical, you only have 2 options, up or down. So when you're giving your translation, you'll be given 2 values, one on top and one underneath. Notice I use H and V. The top number is always the horizontal movement, always. And the underneath value is always the vertical movement, all right? Now, here's the thing. Let's deal with the top one first, the horizontal. Anytime the top number is a positive value, you always move it to the right. If the top number is a negative value, you move it to the left. So I know somebody's going to ask, well, if the top number is 0, what happens? Because 0 is not positive or negative. Whenever it's 0, the good news is it means you don't have to move it horizontal. You just leave it where it is in that particular horizontal position. The same concept applies for the underneath value. Since the underneath value represents vertical movement, if the underneath number is positive, you move it up. If the underneath number is a minus, then you move it downwards. Obviously, you're going to need to see an example of this to practice it. But take down everything on the screen. Let me know when you are ready to move on, right? Take down everything, right? And just remember, the top is always horizontal. The underneath is always vertical, always, no exceptions. All right, so let's continue the story here. So I think we could all assume that Joanne here, that's her name, I believe that's her name, right? Got bitten by the wolf. I think that is the assumption here, right? So what do you all think is going to happen? Let's make a small guess. You think she's going to turn into either a werewolf, or do you think she's going to turn into a vampire? Well, what do you most likely is going to happen? Well, what do you think? Right? So obviously, me too. Obviously, she's going to turn into a werewolf, right? Right. I mean, if you get bitten by a wolf, it's not like a bat, right? So, what do you all know about werewolves? That they do what? They change into a werewolf, but they need a full what? What do they usually need to turn into the werewolf? A full moon. And of course, if you look at the picture on top there, you'll see the moon blacked out. So obviously, it's going to turn into a full moon. So anyway, Joanne now is wandering around the forest after she buried her husband. She comes across a cottage in the forest with a happy family singing happy songs. I don't think this is going to end well. All right, so what's going to happen now? The full moon is going to come out. Joanne is unaware of what has happened to her. She has no idea what's going to happen to her. Because of the full moon, she changes into a werewolf. She cannot control herself, and she goes into the cottage. Not a very bright ending here, guys. Not a very bright ending. Right, so soon the laughter in the house was replaced by screams as she devoured the family one by one. Anyway, let's move on. Let's move on to something happier. Triangles. That's happier. All right. So let's do our first, right? Our first translations questions. Translations question here. Right. Now, I use the word vector here, right? Whenever they ask you to find a translation, you see the two values here, the horizontal value and the vertical value. They just call it a vector. They could also call it a matrix, but vectors and matrices, vectors is a topic we haven't done as yet, but I'm letting you know upfront. Vectors and matrices are kind of connected. So you see the two values that they're asking you to find. Sometimes they call it a vector, and sometimes they will say find the matrix. But anyway, let's see if we could find the two values. Let's assume, right, this is the original triangle. So the examiner tells you the red triangle is the original triangle. And the darkish triangle here is the image. The image is what comes after. So original is the first, the image comes after. Do you all notice you kind of slide the triangle upwards? Like you didn't change the size of the triangle. You didn't really change the orientation. Orientation means we didn't make it upside down or turn it to the side. The triangle was facing upwards. At the end of the question, it's facing the same direction, not a single change. So do we all agree that this is a slide And remember, the fancy name for a slide is a translation. Now, the examiner is asking, here's what they're asking. They're asking, what does it take for this triangle to slide from the red position to the darkish position? Choose any two common points on the triangle. For example, I think we could all agree that this point was moved to this point. You only have to take two common points. And what you want to do is kind of trace the horizontal and vertical movement. Which one did I say to focus on first? The horizontal movement or the vertical movement? Do you all remember? Well, which one are we going to concentrate on first? The horizontal, right? Just to keep it simple. So pretend you're standing at point A and you want to walk to point B, but you're only allowed to move horizontal or vertical. You can't move slanted. So you begin to walk. So you walk 1, 2, 3, 4, 5. So you walk 5 places, right? To the right. And when you reach here, obviously you have to go upwards, right? So we're going to go 1, 2 steps upwards. So let's put this. So you move 5 spaces to the right, okay? 1, 2, 3, 4, 5. Now, did I move to the right or left? Obviously, we're moving to the right. So you think this 5 should be positive or negative? Go back to your notes. When you move to the right, is it positive or negative? Positive, correct. So I don't have to put the positive 5 here because the positive is understood. And when we finally reach here, we have to move upwards. Now, when we're moving upwards, we're moving 1, 2. Now, since we're moving upwards, if you look back in your notes, upwards is classified as positive. So you know what's the answer to this? The answer to this question is just simply the horizontal movement is 5 and the vertical movement is positive 2. Once again, you don't have to put the positive because if you don't put anything there, the positive is understood. Ta-da! Easy or hard? Which one you all prefer, this or the work from last week? Believe me, it's real easy. I don't think translations itself is going to give too much problems. All right, but let me change. You don't have to take down anything here as yet, right? Now, but these examples, I wanted to stick in your head, right? Let's do it a different way. Let's say we switch it around. Let's say that this is no longer the image. If this was the original and this was the image, so it's the opposite way. So in other words, you want to walk from B to A. Like let's say it's the reverse question. If you are now standing at B and you want to reach position A, let's see what answer we would get. Well, would we get the same answer? Do you think the answer would still be 5-2 if we're walking the opposite way? What do you all think? I don't think so, right? Well, if you walk in the opposite way, I have a good feeling you will get the opposite answer. But anyway, let's reason it out. So you're standing at point B, and we want to move back to point A. So we have to do horizontal first. So we walk 1, 2, 3, 4, 5. But we walk in 5 to the left. So it's -5. Remember, when it's a horizontal movement and you're walking to the left, it's classified as negative. And when you reach here now, you have to walk, keyword, downwards. But you walk downwards, how much space is 2? And if you move down, it is negative. So we get the opposite answer. So translations, it's real easy. Anytime you walk the opposite way, you just have to make what? The signs the opposite. It couldn't get any easier than that. Okay? So when you walk the opposite way, you just make the signs the opposite. All right? So if anybody wants to take a screenshot, feel free, but I don't think you really need to take down anything much here because we have a few more examples to do and it's going to stick in your head. Okay? But whoever wants to take a screenshot, I'm giving you 10 seconds. Oh, so Joanna, let's see what's going on with Joanne. Remember, she turns into a werewolf and it happens every time there's a full moon. So let's see what happens. All right, so this is supposed to be one of those dramatic moments like in a movie, like when you see like little screenshots of all the victims pass by. All right. I don't think I'm good at making scary. Usually my scary stories come off as comical. Like when you watch a really terrible movie, you end up laughing instead. All right. So someone had a question. You remember I said you could choose any point on the triangle, right? So whenever you're trying to figure out how to slide it, you just choose any two similar points. It doesn't have to be the top of the triangle, just two similar points, right? Right. So in this question here, right, I'm going to call this the original triangle, and I'm going to call this one the image. We're going to choose two similar points. I don't always have to choose the top of the triangle. So I'm going to choose this point here. I'm just going to highlight it here. I'm going to call this point A. And I think everyone, no, that one's too hard. That one's too hard. Let's just choose the top one, right? That one will have the less clutter. So let's choose this as point A, O for original, I for image. So we're moving from point A to point B. I want you all to figure out the vector. And you have to let me know if it's positive or negative, right? So figure out the translation, the two values that describe this translation. Send it to me on the chat. Obviously, you might have to put your finger on the screen itself to count out the blocks, how much horizontal blocks is moving, how much vertical blocks is moving. But take a minute and let's see what you come up with on the chat. All right, so remember, we're starting at A. And we're supposed to get two values, right? So we're supposed to get two values. The top one is the horizontal movement. The underneath one is the vertical movement. So if you're starting at point A, you have to move 1, 2, 3, 4, 5, and 6. So you move 6 to the right. Remember, look at it, you're moving to the right. So the top number is going to be positive 6. You have we all agree that we would do the horizontal movement first, and the horizontal movement, the value always goes on top. When you reach here now, then we have to move how? Downwards. 1, 2, 3. But we're moving downwards. So it should be what? -3. Too many people put 6 and +3. It was 6 and -3, because we're moving +6 this way and -3 down. But -3 means you're moving downwards. Okay. Right? Now remember, according to the instructions, I clearly said that we starting at O. O is the original. Remember, that was my verbal instructions, right? So you're starting at the deeper triangle and you're moving to the red triangle. So for those who got it wrong, you think you saw your mistake? If you slide this way, the value, that translation will be 6 - 3. That is what it takes to move the dark triangle to the red triangle. Make sure you see your mistakes, right? But is there a way to test our answer to know if we are correct, right? Is there a way to test it? Is there a mathematical way to do it other than counting the blocks, like to know if we are right or wrong? Now, remember, this 6 - 3 applies to all the points on the triangle, right? Because I guarantee you, if you took this point here, right? If you took this point here, let's call this C. Obviously, here is the corresponding point. To move from C to D, just test run it. So you have some confidence in your answer. See if you would get the same answer, 6 minus 3. I'm trying to prove it doesn't matter which point you choose, right? Because people are still asking, hey, do we have to choose the top point or can we choose any other point? I just want to prove it here. Choose C and see if it takes the same value, the 6 minus 3, to reach the D. So I'm going to test run it here too, right? So everyone could see it. Because remember, this point did change to this point. So let's do it. Let's see if we get 6 minus 3 again. 1, 2, 3, 4, 5, and 6. See, we end up moving positive 6. Well, 6 to the right. So it's a positive value. And when we move downwards, 1, 2, and 3. That's minus 3 because we moved downwards. So you're still going to get what? 6 minus 3, right? Some people went by this point by mistake. Did C change into this point? No. If you look at it, C moved to this point. These 2 points are related. Some people think C and this point are related. That's not true. E and F are related, right? Right? I know it might be a little confusing, but you got to look at it properly. All right, but what I want to do now is get to a mathematical way, like a calculation way to show you all that we are correct. Let's take point C. Anybody wants to tell me what the coordinates of point C is? Let's go ahead. What's the coordinates of point C? The X value is how much? Minus 3. And the Y value is what? 4. Everyone could agree with that, right? Minus 3, 4. All right. Let's take this point and apply the translation. Remember, the translation is 6 minus 3, right? Let's see if our translation, our answer, if it is correct. What did I tell you about translations? Do we add them or do we multiply them? I mentioned that at the beginning of class and it was good news. We add them. All right, so here's what you're going to do. We're going to take point C, but we're going to write it vertical. I think we all are accustomed to this now. Whenever we're taking points and we're going to apply whether a transformation or a translation, we always write it vertical. So the minus 3, the X value goes on top and the Y value goes underneath. Let's apply the translation. So we're going to add the translation. I'll just put T for translation, right? What's the value of the translation? 6 minus 3, right? Work that out for me and tell me what 2 values you get. I want to know what 2 values you will get here. You're just adding the 2 top numbers and you're adding the 2 underneath numbers. So it's minus 3 plus 6 and 4 plus minus 3. Remember, when a plus and a minus touch, you get a minus. Okay. Let's work it out. Minus 3 plus 6 is, yes, now, minus 3 plus 6 is 3. 4 plus minus 3 is 1. You get to test run it on a calculator, right? Well, right now I don't have time to, well, I'm not supposed to be going through addition and subtraction of positive and negative numbers at this point, right? Right. So the answer we get is 3, 1, right? Well, when we add the 2 top numbers and add in the 2 underneath numbers, is that the coordinates of D? Look at it. And we're trying to say, when we take C and apply the translation, it's supposed to move us to point D. Is D really 3, 1? And if you look at the graph, yes, look at this. D is what? 3 on the X and 1 on the Y. So the translation is correct because I could take a point, apply the translation. Apply the translation means we could add it to the point. And if we do that, we're supposed to get the location of where it's supposed to move. right? Right? So it will always be add, right? So minus 3 plus 6 and 4 plus minus 3. Remember, it's by now everyone should know that 4 plus minus 3, a plus and a minus, if they touch, will give you a minus, right? So that's the assumption, right? Great. So I just wanted to prove to you all, right, that the answer was correct. Everybody okay so far, right? That you just add in the translation. Now, to know which method to use, that will just take practice, meaning that we have to go through past paper questions, and we will be able to figure out if they want us to count it, right? Or they want us to, physically add the translation, right? But give them a chance to read the past papers. So, it takes practice or experience to, when you do enough past papers, to know which method to use, right? It's actually not that hard to figure out which method. All right, so I'm ready to move on, right? Whoever wants to take a screenshot can take a screenshot, but it's not going to be necessary. All right, so Joanne obviously is very distressed because, she can't help but turn into a werewolf. And of course, she's going to feel guilty, right, about the amount of lives she took, right? So she visits a gypsy, right? And the gypsy gives her a way to control her turning into a werewolf, all right? So you all remember from last week, right? Remember how Joanne, when she was a ghost, she would always be carrying around this pendant, and that was the most precious thing to her when she was alive. I'm not too sure if you all remember from quite last week. All right. So do you all think this gypsy is a good person or a bad person for helping out Joanne? It's so nice of her to help out for free, right? Just went to the gypsy, gave her a pendant. All right. But there's a little twist to this. The gypsy wants 400 gold coins, which is a lot of money back then in 1845. That's like a fortune. Or she's going to tell everyone Joanne's secret. Right? And of course, Joanne responds like this. And that's the end of this story. All right. So it turns out the gypsy was a Trini. That's a little joke there. I'm sure you all know a friend like that. All right. So this is the last horror story I had, right? So obviously, we have a different game to play in a little while, right? I was working on another horror story. Well, I doubt you are calling them horror stories now. It's probably comical stories for you all, right? All right. So let's move on. So here's what I want you all to do now. I want you all to try this question. The examiner goes, you open the exam paper and you see that the examiner has already drawn a triangle for you. This is the original triangle, right? And they want you to translate it by 6 minus 2. So obviously this triangle is going to move to a different location on the map, on the graph. But anyway, let me give you the points here. I know it's going to be kind of hard to see. Point A is minus 3, positive 3. Point B is how much? Minus 2, minus 3. And point C is how much? Minus 5, minus 2. And they want you to apply this translation to it. I want you all to find the new coordinates, A prime, B prime, and C prime. And then, kind of sketch where it would be on the graph paper. It doesn't matter if you understand it fully or not, just give it a try. You can even though you think you might get it wrong, just give it a try. You might surprise yourself. Okay. I'm going to give you 5 minutes to do this question. Since there are two ways, before someone asks me, 'cause I know I will get the question, right? Would you get more marks for doing it one way rather than the other way? Now, once the examiner doesn't specify which method to use, like me, I didn't specify which method to use. It doesn't matter. You're going to get the same amount of marks for any method you use, right? And as far as I can see in the exam, from going through past papers, when it comes to these particular type of questions, I've never seen the examiner actually state which method to use. It is just tell you do it. So it doesn't matter. But obviously, one method would take more time, and one method might take what? Less time. So obviously, you want to choose the method that takes a smaller amount of time. So let's interpret this translation. Remember, the top value is what? The horizontal movement, right? I shouldn't put an arrow here. The top value is the horizontal movement, so I'll put H, and the underneath value is the vertical movement. According to the top value, are we moving the triangle to the left or to the right? According to the horizontal value. Ask yourself whether it's positive or negative. We're moving it to the right, right? Let's reading the answers here. Remember, this 6 is positive, so we're moving it to the right. As for the vertical movement, are we moving it up or are we moving it down? Look at the vertical value. It's a negative. Look back in the notes. What does a negative value mean with vertical? We're moving it downwards. So in other words, we're taking this triangle and sliding it 6 spaces to the right, and then we have to move it 2 places downwards. So how would that look if I didn't want to do any calculation? Let's start at point A. So for point A, it means we're moving it 6 spaces to the right. And when we do that, we complete it by moving 2 places downwards. So help me out here. I'm starting at A. Moving it 1, 2, 3, 4, 5, 6. So when we reach 6, we have to move how much now? 2 spaces down. 1, 2. Won't that end up over here? Well, what's the coordinates over here? If we move A and move it to A prime, which is 6 spaces to the right and 2 spaces downwards. What's the coordinates? 3, 1. I think everyone could see that, right? 3 on the X, 1 on the Y. Then we can do it for all the other points. We can do it for point C. Let's do that the same exact thing for point C. We're going to move it 1, 2, 3, 4, 5, 6. And when we make 6, we move C how much downwards? 1, 2. And we're going to get C prime. And what are the coordinates there? 1, -4, right? For point B, we do the same exact thing. We move it 1, 2, 3, 4, 5, 6. And when we move it 6, according to the instructions, we have to move it 1, 2. That takes us down here. D prime, which is how much? 4 -5. And of course, when we connect this triangle, the point, doesn't it look like it got slide 6 spaces to the right and then move 2 places downwards? I don't know if you all can imagine that. The whole thing slides 6 spaces to the right and then drops 2 spaces downwards. Okay? How much of you all did it that way? To me, this is the long way. And this way, to me, it's kind of easy to make mistakes because, when you're under stress in the exam, you might count 7 instead of 6. Your hands might be a little shaky. But how much of you all did it this way? The manual way, where you count all the blocks. Let me know in the chat because there's another way to do this, right? Right? To me, this is the long way, right? That is just me. How I would normally do it in the exam, and this way would not give me more points. It will definitely, I like to calculate. I have no problems with calculations. So here's what. Let me take point A. How much is point A again? Minus 3, 3. We write the x value on top, the y value underneath. X always goes on top and y goes underneath. And then we apply the translation. How much is the translation again? 6 minus 2. So when we apply the translation, better known as adding the translation, we're supposed to get the new position for A prime. Let's see if we get the same answer, 3, 1. Minus 3 plus 6 is positive 3. You can double check it on your calculator. And 3 plus minus 2 is 1. Didn't we get the same answer? I didn't have to count all the blocks and go downwards. I could have just used calculation to figure out the new A value. And I could do the same thing for point B. Isn't point B right now minus 2 minus 3? If I take point B and apply the same translation, which is 6 minus 2, minus 2 plus 6 is 4. Minus 3 plus minus 2. Remember, when a plus and a minus meet, you get a minus. Minus 3 minus 2 is minus 5. Look at it. We got the same value. So it's supposed to be B here, right? 4 minus 5. Same exact value. And of course, I guarantee you, if I do the same thing for point C, minus 5 minus 2, and I apply the same translation, minus 5 plus 6 is 1. Minus 2 plus minus 2 is minus 4. We get the same answer for C prime here. To me, I find this way easier. I know some of y'all don't mind counting it, right? I know you don't mind counting it, right? Here's what I want you all to do, right? I need for you all, this is the first time I'm going to make you all draw a graph and take down this fully for me. So I'm going to give you all 5 minutes. Take down everything here. You could actually draw the lines going across and coming down. If you're doing it the drawing method for the examiner, this is what I advise. You draw little dash lines like this going across, like this. And when you reach here, you move it downwards. That is what that is your working if you're doing it the drawing or counting method. For each point, use dash lines and show the examiner you're moving 6 and then downwards. Right, so the examiner will have some idea what was going on in your head. Right? It doesn't matter if it's a triangle or a square. If it was a square, you would just have to do the calculation 4 times, right? 1 for each point. Or if you're doing it the drawing method, you will have to draw 4 pairs of dash line. The shape doesn't matter. It's the concept. You could have a 10-sided shape. You just need to do the calculation 10 times. Once for each corner or each vertex of the triangle. All right, so take down everything on the screen and both methods. Take 5 minutes and let me know when you are finished. All right, guys, so since the horror stories are over, we have a new little game to play at the moment. So I hope no one saw this game already. If anybody here in these Saturday classes, or you know I'm not really supposed to be in the Saturday classes, but the Saturday classes are in Form 2s and Form 3s, right? The premise of the game is this. It's the summer holidays. You're basically doing nothing around the house. Your parents get angry and kick you out of the house, right? And tell you get a job. Okay? Right. Do me a favor. Get a blank piece of paper. Go behind your book or look on the ground, wherever behind the fridge, wherever you have blank paper. All right? Get a blank piece of paper and let me know when you're ready. We're going to see who gets the most amount of money today. You're going to get a whole set of odd summer jobs, right? A whole set of odd summer jobs. And you're going to be collecting money. And let's see who can get the most amount of money. Right, so people are ready. Great. But your parents are not that mean. Before they kick you out of the house, they tell you to choose a box. Everyone choose one box. It's either A, B, or C. The boxes contain money. Starters money to start up a business or whatnot. Let's see if you get lucky. You cannot change your mind. Huh? So choose and stick with it. Right. I'm gonna put some happy music here while you all choose. All right, let's see if you guys got lucky. For those on YouTube, come on, send it, send it, send it. Let's see. If you chose A, put down $50. If you chose B, $50, and C was the best choice, $80. Believe me, the starters money, even though somebody might start with less money than you, I've seen people win even though they chose what? Less money, right? That is all on chance. So write down how much you got on a blank piece of paper. Right. So guys, this is where the homework is going to really, really help. Now, if you all cannot multiply a big matrix, well, you call this a 2 by 2 matrix by another 2 by 2 matrix, right? You're going to have to resolve it after class today, because I'm not going to slow down the class today to review how to multiply 2 by 2 by another 2 by 2 matrix, right? That was homework, and you had 3 weeks to come prepared for it today. All right, and just like I mentioned last week, I will be moving at the pace of the persons who invested their time to do the homework and took time and effort to come prepared for today. So how much people are like that? Okay, they're 100% prepared to multiply 2 big matrices, right? Remember, that was your job, right? I did my part of the job, right? Let's see if you did your part. Great. Right? And of course, like I said, all hope is not lost. If you're unable to do it, it's just after class, you will have a chance to review the homework, right? And then you can review this part of the recording and you realize, wait, no, everything makes sense now, right? All right, so here's what these types of questions are about. They're very rare in the exam, but they do come. It's called combining transformations. That's when you want to do more than one things at the same time. Like, for example, all the time, when we've been doing questions, I might ask you to do just one thing. I might ask you to reflect something in the x-axis. That's just one thing. Or in another question, I might say enlarge the question. The triangle, or rotate it, but it's only one thing I'm asking to do at a time. Suppose the question comes like this in the exam. They want you to come up with a matrix that will do 2 things at one time. It will take the shape, whatever shape it is, right? It could be a triangle, it could be a square. They want you to reflect it in the y-axis and then enlarge it by a factor of 3. So they want you to do 2 things, but they don't want you to do it separately. They don't want you to take the triangle, reflect it in the y-axis, get an answer, and then take that new answer and enlarge it by a factor of 3. They want one matrix that will do 2 things in one shot. The order matters. Look at this. Which one are they asking you to do first? The reflection in the y-axis or the enlargement? This is where your English skills come in a little bit. Not too much, just a little bit. Which one do they want you to do first? Reflect or enlarge? The order matters. If you mix up the order, you're going to get the question 100% wrong. Which one comes first? The reflection in the y-axis or the enlargement of 3? Clearly from the sentence, they want you to do this one first, right? Because they want you to reflect it in the x-axis and then, so this one comes second. Now, if you look back in the formulas I gave you, right? Do you all see a formula for reflection in the y-axis? And do you see a formula, a matrix to enlarge it by a factor of 3? I said x-axis, I mean y-axis, a small thing there. Look back in your notes and see if you see 2 matrices that will reflect in the y-axis and enlarge, and an enlargement matrix. Make sure you see it. When you see it, it's an excuse for you to make you flip back in your notes to get, reaccustomed to it. Right? It's always good to know how your notes are organized, where you can find what where fast. Right. Now, here's the thing, right? If you notice, you all notice this here is a reflection in the y-axis. Everybody understands that this one here is a reflection in the y-axis, and this one here is an enlargement by factor 3. Remember, if it's an enlargement by factor 3, that's the one with k is 0, 0, k. You would replace the letter k by the factor. But in this case, the factor is 3. But you all notice something kind of strange here. When you to combine both matrices to get a matrix C that will do two things at once, you have to multiply both matrices. But you all notice something that's not common sense here, right? Even though they want you to do the enlargement second, you notice they put that matrix first. And even though they ask you to do the reflection first, you notice that matrix comes second. It's just something you have to get accustomed with. Whenever you're combining two matrices, so you get one matrix that will perform both at the same time. This first thing they want you to do comes second. And the second thing, you have to put it first. It's just something you have to get accustomed with. If you had put the first and the second, like what your brain is normally telling you to do, you will get the wrong answer in the majority of the cases. All right? So do you all think you all can multiply out these two matrices and you will get 4 answers? Get the 4 answers for me. And those 4 answers in that matrix would actually reflect something in the y-axis and then enlarge it by a factor of 3. Right? Let me know what 4 values you get. And of course, this is the part I'm not going to review in class, right? I'm just going to put the answer and you all can just confirm whether you had it or not. Okay. When you multiply, right? The first one here I'm getting is minus 3 on top. Then I'm getting 0 underneath. Then I'm getting 0 here. And then I'm getting positive 3 here. How much people got that? When you multiply, like I said, if you're a little confused on how to multiply matrices after class, you could always resolve this, right? Just know that let's keep it simple, right? When you multiply these two matrices, you would get this answer. And you see this matrix here, right? If you take that matrix and multiply it by all the points on the shape, you will notice that the point would get reflected in the y-axis and then enlarged by a factor of 3, right? So take down the answer, right? Even if they got it wrong, take down the answer. Take down everything on the screen. We'll see how much examples we can get through today. Right, so take a half a minute and we will move on. Oh, y'all deserve a small break there. All right, so remember the startup money that your parents gave you. Your first job, you decided to take up your old bicycle, clean it up, and make a pot of soup and ride around the area to sell. A good idea. That's a really nice idea, to be honest. Instead of a doubles man riding around the place, if there was someone on a bicycle selling soup, I might actually buy from them. Which one do you all want to sell here? Which one do you think is a good idea to sell? Chicken soup, veggie soup, or beef soup? Which one do you think will make the most amount of money? You cannot change your mind. Whatever you choose, stick with it. Right now, I really can't remember. I made these beats a long time ago. So I'm going to go, but I like chicken. So I'm going to go with, actually, no. When I buy from outside, I just only buy veggie. I'm going to go with veggie soup. Right? All right, so let's see which one you got lucky with it, guys. For those who chose chicken soup at $40, that was a good choice. It made $40 profit. Not a bad choice. Beef soup, that was a big seller. Apparently, you made a profit of $200. So adding $200. Unfortunately, veggie soup, you made a loss. So minus $10. So apparently, not much people were buying the veggie soup, right? Let's move on. Actually, I'm kind of like this one. So, do you all think you all can do this one for me? Make one matrix that will rotate something by 270 degrees clockwise. Remember last week we did rotations, huh? And whether it's clockwise or anti-clockwise, it has two slightly different formulas. And then they want you to reflect it in a line y is equal to minus x. Make one matrix that will do those two things in that particular order. Good luck. You have 5 minutes. Obviously, I'm going to work it out after. I'm working on the whole thing as that. But remember, they want you to do this one first, the rotation, and they want you to do this one second, right? So remember, the second one comes first, and the first one comes second, right? A reflection in the line y is equal to minus x. I believe it was this matrix, right? 0, -1, -1, 0. Everyone agrees with that? Number is a reflection in the line. Look at minus sign here. Y is equal to minus x. Correct so far? Great. Now the other one, the rotation by 270 degrees clockwise. Let me get a different color here. Remember, it's one of the rotation matrices. I believe it was the cosine theta. If it's clockwise, this sine theta is positive, but the one underneath is negative. Make sure, I don't know if you all saw that, right? That you had to use this one. The clockwise one is where the minus sign is by the underneath sign, right? Anybody disagrees with this? Some people telling me I have this one wrong. I think this correct, and guys, it's a reflection in the line y is equal to minus x. I double checking it in the notes and everything here. I think I have it correct. Unreal people. Since this is the correct formula, right? Since it's 270 degrees, we have to replace all the thetas with what? 270. And remember, make sure your calculator is on the correct mode. We went through this last week, right? So I'm not going to spend too much time on it, but make sure your calculator is set to degrees. Make sure you're seeing the letter D or DEG to the top of your calculator. All right. So I'm going to put it on my calculator here. I'm going to type in cosine 270, sine 270. In other words, I'm going to get 4 numbers. Cosine 270. Double checking it. Cosine 270. I'm getting 0 here. Sine 270. I'm getting -1 here. When I type in minus sine 270, I'm getting +1 here, right? And I'm going to get 0 here. Make sure you get those numbers there. Right? Remember, the second comes first and the first comes second. Recording. Right, so for recording purposes, when you multiply the two matrices, this is your final answer. That matrix will do both things at the same time in that particular order. All right, go guys, go guys. So you have another business plan. So you go back to your house and say, hey, you ask your mom to help you grow plants. Small plants are like seedlings. You know, and she agrees and says, all right, let's start a small business together. What do you all want to grow and sell? Tomatoes, cucumbers, or kale? What do you think is a good idea for a small business? A lot of people are going with those cucumbers. All right, let's see. All right, it seems like the tomatoes was a pretty good idea. $50 profit, so tomato people add food there. Cucumbers, not bad. $40 profit, but the kale, in case you all don't know, kale is really difficult to grow. All right, so you did a loss of $20. So kale people minus 20. Let's move on. All right. I want you all to try this question here, right? Now, this is like an official past paper question. I just, typed it back and whatnot. I don't know if you all can see the points clearly here. I'll call this A, I'll call this 1 and B. See? This is one I want you all to draw. So you don't need graph paper, right? You can just take a ruler and draw a horizontal, a horizontal and vertical line. Put these points in. A is 2, 2, C is 4 minus 1, and B is 2 minus 1, right? I want you all to draw that triangle on some makeshift graph paper, and then I want you to try this question here. What do they want you to do with that triangle? They want you to enlarge the triangle. We got a different color here. Enlarge the triangle by a factor of 2, then rotate it by 90 degrees counterclockwise. In case you didn't know, counterclockwise is the same thing as anti-clockwise. Counter and anti is the same thing. So the first thing you have to do is get the matrix that will do those two things in that particular order. And when you get that matrix, you have to multiply it by each point 1 by 1. So you can imagine the amount of marks you're going to get for that particular question, right? I could see you leaving the exam with about 8 or 9 marks for that particular question. Anyway, give it a try. Once again, you don't always have to be 100% correct. You just have to try your best, okay? Good luck. 10 minutes, you think that will be enough? Not true. I don't think 5 will be enough for this. I think you need 10 minutes because you had to draw it out and whatnot. Good luck, guys. Remember, the first thing you're doing is the enlargement, right? So the first thing that's come what? Second. So let's see. The enlargement, since that is first, that has to be written second. So the enlargement, did you all get 2002? I think that's the easy one. That's the enlargement, right? 2002. Looking correct so far? For the enlargement. Now, the other one is a rotation anti-clockwise. So the anti-clockwise is this one. So it will be cos 90 minus sine 90. Sorry for the small writing. It's hard to fit in everything here. And then it's sine 90, cosine 90. We good so far? The minus sign is the one that's on top for anti-clockwise. So you just have to type in cosine 90 minus sine 90, and you'll get 4 numbers, right? Cosine 90. I think it's supposed to get 0 minus 1, 1, 0. And remember, we multiply it by 2002. When you multiply these two things, right? Remember, this is the one that they're asking you to do second, and this is the one they're asking you to do first, according to the sentence here. Multiply those two matrices, you will get one matrix. That one matrix will perform both transformations, but in one shot. You still have time. When you multiply those two matrices together, we're getting 0 here, 2, minus 2, and 0. We can all agree with that? That looking correct? 0 minus 2, 2, 0. Great. Now, that's not the end of the question, right? We now kind of in the middle of the question. What we need to do is take this matrix, 0 minus 2, 2, 0, and we have to multiply it by all the points, one by one, for the examiner. So for point A, right, this is point A, we have to multiply by 2, 2. Remember, you're writing it vertical. Then you take the same matrix and multiply by point B. Point B is how much? 2 minus 1. And then you have to do the same thing for point C. So you see how much work this is, right? So take your time, multiply by point A, you will get A prime. Then you'll get B prime, and you will get C prime. And then you plot the new points. And the new triangle you get should look like it got enlarged by a factor of 2, then got rotated anti-clockwise by 90 degrees, right? So when you see the answer, it should look like that particular transformation. You still have some time, you still have some time. But the first one, when we multiply it, we're getting, I'll move this to the other side here. You're getting 0, that's now, minus 4, 4. Yes, now just making sure. This one is positive 2, 4. And point C is positive 2, 8. Looking correct so far, guys? I'm looking at everyone's answers here. Yeah, a lot of people are saying the same thing that I have here, right? So let me plot it. Let's see if at least the triangle looks, twice as large. So A prime is minus 4, positive 4, right? I'll put any points there. B is what? 2, 4. And C is 2. That's just off my screen there. 2, 8. That looking like it? Well, when you plot it, you see, it looks like it got rotated, right? Like it's definitely twice as large, right? This is A prime, B prime, and C prime. It not only got twice as large, but you notice this point went downwards. This point is no longer facing up, it's facing to the left. So to me, that actually looks like it got twice as large and, it got rotated. But plot it on your makeshift graph and let me know if you're getting roughly the same thing I have here. Right? If you got out this entire question, feel real, even if it didn't get it out, but at least you understand it now, feel real proud of yourself. And this is considered to be a real difficult question. This is probably the hardest question you can get. I can't imagine anything else harder than this comment, to be honest.